So far we examined two of the potential ways that you can solve quadratic functions. One is by factoring. The only problem with factoring is that all quadratics factor. You can always use completing the square, although it probably won't be your first choice just because of the amount of work that is done, especially if you have leading coefficients. The method that many of you are familiar with is the quadratic formula, and we've had several practice rounds on this, so we're going to look at a couple of quick examples of applying the quadratic formula to solve a quadratic equation. And this will always work. It's a never-fail method. That's what's nice about this one, and also completing the square. It really is also another fail-safe method. It will always work. We're a little more familiar with this, so you'll probably gravitate towards this, but I'm also going to keep pushing and asking that you do the completing the square method also for your assessment. So first plug, make sure that you've always got these things in standard form. And this one's in standard form, so that means you got our ABCs right in order. So in order to find the x's that solve the solution, we always take the opposite of b, or the negative of the value of b. And b in this is a -4. Always take the number with the sign in front of it, plus or minus the square root of b squared, and b is a -4. We're going to square it, minus 4 times the value of a, which is 1. Coefficient of a, times the value of c, which is 15. You want to divide all that by 2 times a, which is 2 times 1. Okay, so now we're going to do our calculation. So the -4 is a +4, plus or minus the square root. Make sure that when you square this, you always get a positive, whether it's a -4 squared or a +4 squared. Square is going to give you a positive, and 4 times 4 is 16. You only have one negative here. It's a -4 times 1 times 5, but that's going to be -60 all over 2 times 1, which is 2. So now we have 4 plus or minus the square root of, and 16 minus 60 is a -44 all over 2. We just talked about imaginary numbers and complex solutions, so this number is going to have to be resolved using complex numbers, so it's going to be 4 plus or minus the square root of 44i, and the square root of 44, I'll take it a little slower, 44i all over 2. The square root of 44 has a perfect square in it, so it's 4 plus or minus the square root of, it's 4 times 11i all over 2. The square root of 4 is 2, so we're going to rewrite the square root of 4 as 2. We're going to bring that out there, so it's going to be 4 plus or minus 2 times the square root of 11i all over 2. Remember, in a complex number, you need to finish it with your standard form a plus bi. So I want to break up this fraction into 4 divided by 2 plus or minus 2 times the square root of 11 all over 2i, and we'll simplify one last time. It's 2 plus or minus square root of 11i. Now those are your solutions for that quadratic equation. Okay, so don't be surprised if you're going to run into some of these solutions that have complex solutions to them. We're going to take a look at one other one, see what other kind of varieties that we have in here. So this one is 4x squared minus 2x plus 9. It is in standard form. We'll go ahead and apply our quadratic formula right away. We can find the values of x that solve this equation by putting in the opposite of our b value, so opposite of a -2, plus or minus the square root of -2 squared, minus 4 times the value of a, which is 4, times the value of c, which is 9, all over 2 times a, and 2 times a is 2 times 4. So we have 2 plus or minus the square root of 4 minus 16 times 9 is 144 all over 8. Now we'll do another round of simplifying. That means you have 2 plus or minus the square root of a -140 all over 8. Once again, we're going to have a complex solution, so it's going to be 2 plus or minus the square root of 140i all over 8. Now we're going to work with these radicals. What we have to make sure is we put these in simplest radical form. So what I want to search for is for that 140, are there any perfect squares that go into 140? For instance, does 4 go into 140 evenly? So I believe 4 goes in there evenly, so if I take 140 divided by 4, it's 35. So I know 140 is 4 times 35. 35 is a much more manageable number. Are there any other perfect squares that go into that? I know 4 doesn't. Another perfect square I test is 9. Another perfect square I test is 25. I missed 16. But there aren't any other perfect squares in 35. If we go any higher, we're going to be up to 36 will go by. So I want to rewrite this radical of the square root of 140 as 2 plus or minus the square root of 4 times 35 times I over 8. But the square root of 4 can be rewritten, so I'm going to simplify the square root of 4 by putting a 2. So it's going to be 2 plus or minus 2 times the square root of 35 I all over 8. Finish it up by putting in your standard form for a complex number. It's going to be 2 over 8 plus or minus 2 times the square root of 35 over 8 I. Now simplify your fractions and you'll have your final answer. So we'll simplify 2/8 as 1/4, and we'll simplify 2/8 again as 1/4, so it's going to be a square root of 35 fourths I. There's your two solutions. As you can see, it's clearly wouldn't factor. We could still solve it with completing the square. We would get the identical answers, as long as it didn't make any errors there. But I'm showing you and demonstrating to you the quadratic formula. We have 3 ways that you're going to be asked to solve quadratics: the factoring method, completing the square method, and also the quadratic formula method.